So in this lecture, we're going to talk about three cost concepts: economies of scale, economies of scope, and learning by doing. So let's start with economies of scale. Economies of scale exist when the average cost is declining in the number of units produced. So if you take the total cost function, that C of Q that we've used in those other lectures, and you divide it by the quantity of output, if that average cost goes down in the amount of output, then we have economies of scale. If the average cost is increasing in the amount of output, then we have diseconomies of scale. This graph shows that in many cases you can have economies of scale on some range of output and diseconomies of scale on other ranges of output. This graph shows on the vertical axis the average cost, and you can see it is initially going down, then it reaches sort of a minimum, and then beyond there it starts to go up. So to the left of that minimum we have economies of scale, and to the right you have diseconomies of scale. So what are some reasons why you might have economies of scale? Well, one reason is there's sometimes indivisibility of fixed inputs. Maybe you need some machine in the production process, but no matter how many units you produce, you need exactly one machine. Okay, and so the larger your output, the more units you're spreading the cost of that machine over. So that causes the average cost to go down. Another example is specialization. Think of an assembly line. On an assembly line, each person is doing one very particular task. It's kind of mundane, but by doing the same task over and over again, they get really good at it. If you had a smaller level of output, you wouldn't be able to hire all those workers to do that one very mundane task. It might be that one worker has to do a number of different tasks. And without as much practice on any one particular task, they're not as quick or as efficient at completing that task. So specialization is another reason why you can have economies of scale. Why might you have diseconomies of scale? Well, one reason is that as you have a larger and larger organization or more and more employees, then you need to add layers of management. And adding more and more layers of management can be inefficient itself. You need to hire sort of more people overall. So that's a reason why you could have diseconomies of scale. And I think for a lot of industries, the average cost function looks something like what's depicted on this slide here. Okay, so now the question I have is, if I were to give you a cost function, suppose you've already estimated the cost function or someone's estimated it for you. With that cost function, how would you find out whether there are economies of scale or diseconomies of scale? Or said another way, like what range of output are there economies of scale versus diseconomies of scale? Okay. So let's think about what math tool we can use to help us solve this problem. Well, remember, there are economies of scale if average cost is going down as the quantity of output increases. What math concept tells us whether a function is decreasing in the value of an input variable? The derivative, right? So what we need to do is we need to calculate the average cost and then take the derivative. And the range where the derivative of average cost is negative is the range where there are economies of scale. So let's try an example here. Let's assume that the total cost function, C of Q, is equal to 15 times Q squared plus 8Q plus 45. Okay. Now if you were to take the derivative of this, you would find that it is positive everywhere, which makes sense. As output goes up, the total costs increase. But that's not what determines economies of scale. The question for economies of scale is whether average costs, not total costs, but average costs are going up or down in the level of output. Okay, so the first thing to solve this problem, first thing we want to do is calculate the average total cost, and that's just equal to this cost function divided by the level of output, which is equal to 15Q plus 8 plus, and you can't forget this part, 45 divided by Q. Often people forget to keep the constant in there. Okay. And then the next step is to take the derivative of the average total cost with respect to the quantity of output. Okay. And that is equal to 15 minus 45 over Q squared. Okay. And we want to find on what range there are economies of scale. So we can rearrange it some. We can add 45 over Q to both sides. Okay, so we get 15 is less than or equal to 45 over, well, actually it's over Q squared. And then multiply both sides by Q squared. So we get 15 times Q squared is less than or equal to 45. And then we can divide both sides by 15, yielding Q squared is less than or equal to 3. Now you have to be a little bit careful when you're taking the square root, but you can kind of see here that this implies that Q is between minus square root 3 and positive square root 3. Doesn't really make sense to have negative levels of output, so we can just say that Q is less than or equal to positive square root 3. Okay, so to reiterate, we first calculated the average cost. Then we took the derivative of average cost to see if average costs are going up or down in the level of output. And we've tried to find the range where the average costs, or the derivative of the average costs, were less than 0. And after a few sort of simple math steps, we figured out that there are economies of scale when Q is less than or equal to square root 3. So the next cost concept that I want to go over is economies of scope. Economies of scope is sort of similar to economies of scale, but rather than having average cost decline in the amount of output of that one product in question, when you have economies of scope, you have a case where the average cost of producing a given product goes down the more other products the firm makes. And so there's a number of different reasons why we might expect there to be economies of scale. Maybe the most well-known one is fixed inputs which are shared across the different products that a firm makes. Okay, so one really well-known example of that is the basic platform that cars are built out of. So for example, Ford might make the lowest level of the car, and it might share that among the different cars and trucks and SUVs that it produces. And in fact, over time, firms have become increasingly aware of economies of scale and have tried to leverage this. I have an article here that suggests that a couple decades ago, Volkswagen actually had about 38 different platforms for its vehicles. And they actually reduced this all the way down to 3 recently. An even more extreme case is Subaru, who has one platform for pretty much all of its vehicles now. They spent a lot on this one platform. They spent over $1 billion on designing it, which allowed them to make their cars much safer. But then they were able to share this across all their vehicles. By splitting that design cost over all their vehicles, they're able to lower the average cost of a given quality of vehicle rather than separately designing the base platform for each of their vehicles separately. And in fact, the vehicles can actually be quite different than each other. So you can see here are some examples of vehicles which share the same platform. You can see the Mitsubishi Lancer and the Jeep Compass. Those are two rather different vehicles, but they share the same platform. Another example was a Chrysler 300 and Mercedes-Benz E-Class, the Jeep Cherokee and Mercedes-Benz M-Class. Sometimes these are shared across firms. They have some way of sort of contracting this out. As you can see, there's actually quite a few examples of this. Another example of economies of scope is when you have byproducts of one production process that are inputs into another production process. The example I like to give here is beer production and cattle raising. When you make beer, the hops that are left over, they still have some calories in them, but they don't taste very good at all. So you wouldn't really want to make a human food product out of it. You wouldn't be able to sell it for very much. But you can feed the byproducts to cattle. So if you're just a beer manufacturer and you don't have a farm with cattle there too, you presumably will just dispose of this spent hops. But if you have a cattle farm there too, you can then take this hops, which is essentially just trash after you've used it in the beer production process. You can take it and you can feed it to the cattle to fatten them up to sort of sell the cattle for more. So this is an example of the byproduct of one manufacturing process being used as an input in the other manufacturing process. Another cost concept is learning by doing. And the idea here is that as a firm makes more of a product, they figure out their mistakes and learn to make the product for a cheaper amount. A common example of this is LCD TV sets. One of the problems with making LCD TV sets is that a lot of the time, one of the pixels or a few of the pixels don't actually come out as planned. They don't actually work. And so it leaves kind of a dead spot or a black spot on the TV. And if there's too many of those, they won't sell the TV. Now, initially, when they're making these larger TVs, they had a very large, fraction of the, attempts that ended up having some of these dead spots, 40, 50%, something like that. And so that added a lot to the cost of making these TVs because they were actually throwing out a lot of their attempts. But over time, they might figure out why some of these pixels are not actually rendering correctly and be able to improve that process. And then they end up having to throw out fewer of these items. So let me actually show how we would look at this graphically. So I'm actually going to draw two graphs side by side. So in each of these graphs, we're going to have the average cost on the vertical axis. Okay. And on this first graph, I'm going to have output in one period, so the output in period T on the horizontal axis. And on this other graph, so a little better, this other graph, we again have average cost on the vertical axis, but we have cumulative output on the horizontal axis. Okay, so the basic idea is in the first period, you have some range where there's economies of scale, and then some range where there's diseconomies of scale. Suppose that they produce at minimum average cost that period. Next period, through making this product, making this number of units, they actually figure out how to make each level of output cheaper. They figured out what mistakes they were making, they've improved upon it. And so the average cost of any level of output in the second period, I'll label this first one the first period, is now lower. Okay, and so suppose they produce at this same quantity here, and then in the third period, the average cost function is again lower, and so the cost of producing a given level of output goes down each period as they learn more. We can then trace this over to this other graph. We're actually showing on this graph is the minimum average cost. That is, if they try to choose a level of output that would minimize average cost, it's showing what that would be. And we could see that by the time they've produced, let's call this quantity here Q star units, sort of the amount that minimizes the average cost in a given period, they've learned to make it a little bit better. And by the time they've produced twice that amount, 2 times Q star, then the minimum average cost is even lower. And by the third period, when they've produced a lot more and learned a lot more from their mistakes, the minimum average cost that period is actually, actually I should say this is 3 times Q star. Okay, now we don't have to assume that they always produce the same level of output. In fact, if they were to produce more in a given period, they would learn faster. That's the basic idea. Okay, so we covered 3 cost concepts in this second part of the lecture. We covered learning by doing, economies of scope, and economies of scale. All 3 of those cost concepts favor large firms. And actually, regulators might want to allow mergers or allow monopolies when you have those types of cost concepts because firms might then produce at lower overall cost.